welcome to Mavin Academy. Dear students, it is Shahid sir. Dear students, peace and blessing is upon you. Dear students, in earlier classes we have studied about two fields. The one is gravitational field and the second one is electrical field. Dear students, we came to know from these two fields that for gravitational field, when we have two objects of mass m1 and mass m2, these two objects are not in contact but still experiencing a force. It is just because of a field. This field is known as gravitational field. And then we studied about another field, that is electrical field, which is due to charges. Suppose we have two charges. These charges are not in contact. These charges are at different places. This is electric charge. And we know that these charges exerts force of repulsion or force of attraction. And between these two charges there is a field. The field is known as electrical field. This field is known as electrical field. Okay. We came to know from these two fields that the cause here in gravitational field is just because of mass, and the cause of this electric field is electric charge. So you may already knew that these two forces are non-contact forces, both in gravitational field and in electrical field. These bodies are not in contact, but still these bodies are experiencing a force. These bodies are experiencing a field. The field is known as gravitational field, and this field is known as electrical field. The answer is only that this field is just because the cause of mass, and the field is just because the cause of electric charge. Now today we are going to learn about the third field which we have in our nature. The third field is magnetic field. Okay, fine. So what we are going to learn in this magnetic field, which is the third field in our nature. Remember it, dear students. If the two bodies are at different places, at different positions, suppose these objects, these two bodies are at different positions. If they are experiencing a force, that means there exists a field. First, you must understand that if the two bodies are not in contact, whether these bodies are large or small, if these objects are experiencing a force, you must understand there exists a field. That's it. The first which we studied in earlier classes about gravitational field and then electrical field. Now, as I said, that we are going to learn about magnetic field, which is the third field in our nature. Okay, 2 points we are going to learn first about magnetic field. The question in our mind may arise that what is a magnetic field? The first question is that what is a magnetic field? And the second question which may arise in our mind, that is, what is the source of magnetic field? Two questions. What is magnetic field? And another one is, what is the source of magnetic field? Okay. Dear students, suppose we have a conductor. This conductor. And we know that each and every conductor is made up of atoms. And we already know that these atoms are neutral. in nature, right? Is that clear? The net charge of this conductor Q, that is 0. The net charge of this conductor is 0. Now, let us say that we have a charge, we have a moving charge right now in this direction, in this way. And this turns, and it turns, or we can say it bends like this with a certain velocity, that's v. And here we have a charge and its velocity is 0. Dear students, now you may have question, sir, why this turns? Dear students, as I said, suppose we have a charge, we have a moving charge which moves with a certain velocity and it turns, or we can say it bends like this. The question here is why it turns. You can give me simply answer if you are going to pass this video. Yes, you got it right. It turns just because there exists a force. The question is there exists a force, because without force we cannot do anything. It cannot be turned without a force. So here we got that here there is a force, there exists a force. We can simply say it experiencing a force. Because it has a certain velocity and it turns. Here it does not turn, the velocity is 0. So simply we can say that it does not experiencing. It does not experiencing any force. So what is the cause of turning? The force is necessary, sir. Here it experiencing a force, here it does not experiencing a force. That is why here this charge turns like this. Dear students, two things are necessary for experiencing a force. There are two things which are necessary for experiencing a force. The first one, there should be a charged particle. The first one, there should be a charged particle. Is there a charged particle? Yes. The second necessary thing is there should be a velocity. There should be a certain velocity. Is there a certain velocity? The answer is yes. These two things are necessary for experiencing any force. So here there is a certain velocity and a charged particle. There is no velocity, and so it does not experiencing any kind of force, dear students. Here simply we can say that when force exists, the answer is sir, when there is a moving charge. When charge moves. Simply, force exists when charge moves with a certain velocity. And when this force does not exist, when the charge is at stationary. When the charge is at stationary. So dear students, it's very simple till now. Yeah, this is obvious that these three fields are different with one another: electrical field, gravitational field, and magnetic field. Till now हमें ये पता चला कि दो ऑब्जेक्ट्स अगर टच में नहीं है पर फिर भी वहां पे फोर्स एग्जिस्ट है. क्यों? सर सिंपल आंसर है, देयर इज अ फील्ड. सर क्या ये फील्ड सेम है? नहीं, डिफरेंट है. ग्रेविटेशनल फील्ड अलग चीज है, इलेक्ट्रिकल फील्ड अलग चीज है, और देन दिस मैग्नेटिक फील्ड ये अलग चीज है. अभी तक हम ये पता कर चुके हैं इस कंडक्टर में कि अगर इस कंडक्टर में नेट चार्ज 0 है, सो ये आप मुझे बताइए. आई विल आस्क यू अ क्वेश्चन डियर स्टूडेंट्स. इफ दिस कंडक्टर हैविंग नेट चार्ज 0 हैज इट कैपेसिटी to exert any kind of force? Has it capacity to create any kind of electrical field? The answer is no. Isn't it? If this conductor is having net charge 0, it does not experience any kind of electrical force. So that means there does not exist any kind of electrical field. ओके डियर स्टूडेंट्स, सो यहाँ पे हमें ये चीज पता चली है कि सर यहाँ पे विथ अ सर्टेन वेलोसिटी यहाँ पे टर्न हुआ है, और दिस मीन्स कि सर ये टर्न कैसे हुआ? देयर मस्ट बी देयर एग्जिस्ट ए फोर्स. द आंसर इज यस. यहाँ पे फोर्स है. सर कौन सा फोर्स है? इज दैट ग्रेविटेशनल फोर्स? इज दैट इलेक्ट्रिकल फोर्स? द आंसर इज नो. देन व्हाट काइंड ऑफ फोर्स इट इज? द क्वेश्चन इज what kind of force it is. As I said, if there is a moving charge, there exists a force. If there is a charge which is at stationary, there does not exist any kind of force. Dear students, अभी तक ये हमें पता चला we came to know till now that कि यहाँ पे जो ये सारा जो एक्सपेरिमेंट है, हमने यहाँ पे एक्सपेरिमेंटली देखा कि if there is a certain velocity with a moving charge, then it turns. It means there is a force. It experiencing a force. If the velocity is 0, then we came to know that it does not experiencing any kind of force. When it has और एक चीज पता चली, if this conductor having net charge 0, that means it does not create any kind of electrical field. It does not have capacity to create electrical field. एक बात सिंपल है. ओके, तो ये चीज जो है, जो अभी हमने देखा कि जब चार्ज मूव कर रहा है देन इट टर्न्स, और जब चार्ज स्टेशनरी पे है देन इट डज नॉट टर्न्स. तो ये चीज देखा पहली बार ऑयरस्टेड ने. इट वाज सीन फर्स्ट बाय ऑयरस्टेड इन हिज ओन एक्सपेरिमेंट. इवन he was not doing any kind of experiment in magnetism. वो डिफरेंट ब्रांच के थे, वो डिफरेंट डिपार्टमेंट के थे. वो ये ऑल ओवर सडन हुआ, एक्सीडेंटली हुआ. कैसे हुआ? क्योंकि ऑयरस्टेड ने जब पहली बार देखा तो वो कुछ अलग एक्सपेरिमेंट कर रहे थे, वो कुछ अलग चीज ढूंढ रहे थे. ही वॉज फाइंडिंग समथिंग एल्स, but it was sudden, it was accidentally, and he found something new concept in magnetism, something new concept, something new relation between electricity and magnetism. So dear students, तो ऑयरस्टेड ने ये चीज फाइंड आउट किया कि there is a relation between this magnetism and this electricity. तो उसने क्या फाइंड आउट किया कि लुक स्टूडेंट्स, उसने मैग्नेट के बारे में बताया, राइट, मैग्नेटिक फील्ड के बारे में. बट मैग्नेट का कंसेप्ट इससे पहले आया था. ये कुछ 1819 में कुछ इसने एक्सपेरिमेंट किया था फॉरेपस. तो देन क्या हुआ कि मैग्नेट का जो कंसेप्ट है ये उससे पहले था. मैग्नेट का कंसेप्ट उससे पहले था. इज दैट क्लियर? तो दिस magnet is a lodestone. This magnet is a lodestone which is used to attract iron pieces. Okay, suppose we are here to hang a magnet. We already knows that the magnet has two poles. The one is north pole and the second one is south pole. And then we bring this iron piece near to it. And these two objects are not in contact. Okay. सो सिंपली अब हमें यहाँ ये पता चलेगी कि अगर इनके बीच में कुछ मूवमेंट हुई या कोई फोर्स एक्सर्ट हुआ तो हमें पता चलेगा कि वहां पे कोई फील्ड है, क्योंकि हमें पता है कि फील्ड वहीं पे क्रिएट होता है जहां पे दो ऑब्जेक्ट्स कांटेक्ट में नहीं होते हैं. तो when we are going to bring this iron piece near to magnet, then definitely this magnet will attract this iron piece towards itself. Is that clear? Why? Because of a magnetic force. तो यहाँ पे हमें ये चीज पता चलती है कि यहाँ पे जो है, यहाँ पे एक क्रिएट मैग्नेटिक फील्ड होता है. किन से? मैग्नेटिक फोर्स से, मैग्नेटिक फील्ड लाइन से. Okay, so there is a magnetic force. So dear students, when we bring this magnetic needle, and we know that this magnetic needle has two poles, north pole and south pole. When we are going to bring a bar magnet near to it, then what will happen? Dear students, this is the magnetic needle, and it will always remain in this position until and unless any external force will not be applied on it. The north pole will remain this side and the south pole will remain that side. But when we are going to bring this bar magnet to near this magnetic needle, then what will happen? A movement of this magnetic needle will happen, right? In what ways? Like this. The south pole will go towards north pole, and the north pole will goes upward. Why? Because the magnet has a property, same poles attract each other, and unlike poles attract each other, and same poles repel each other. So that means there will be a movement, and this south pole will go this direction and the north pole will goes upward. If we are going to remove this bar magnet, then it will again come its original position. So this is simple. When we are going to know that, sir, is that object a magnet or not, it is a very simple. Physics is practical, dear students. Just do simply one thing. Bring any object and just bring this magnetic needle as well. If you are going to do an experiment, if this needle shows any deflection, any movement, then simply this is a magnet. If it does not show any kind of movement, that means this object is not a magnet. It's simple as it is. The stone is not a magnet. Is that clear? So, dear students, what Orested has found in his experiment, dear students, उनकी टेबल पे कोई एक्सपेरिमेंट कर रहा था किसी इलेक्ट्रिक सर्किट के साथ. तो मान के चलिए एक सर्किट है, तो वहां पे मैग्नेटिक नीडल जो है वहां पे रखी हुई थी टेबल पे. जब उन्होंने क्या किया, स्विच ऑन किया एंड देन पुट ऑफ, तो ही फाउंड समथिंग, some deflection in this magnetic needle. तो he did it again and again. तो सोचिए ये क्या हो रहा है. वो डिलिबरेटली ये एक्सपेरिमेंट नहीं कर रहा था मैग्नेटिज्म पे, बट इट वाज ऑल सडन एज ए सेड कि ये जो मैग्नेटिक जो है डिफ्लेक्शन स्टार्ट हुई. कब? जब वो ऑन कर रहे थे. जब ऑफ कर रहे थे कुछ नहीं दिखा उन्होंने. तो he find that in second case he changed the direction of the current and the direction of the magnetic needle also changes. So in his experiment, he was the first person, he found that where there is electric current, there is a magnetic field. He told to the world that when a moving charge can create magnetic field. What he found? Electric current or moving charge. What is electric current? Moving charge is called electric current. Okay. Electric current can create magnetic field. Okay, dear students, what he did in his experiment? First, उन्होंने क्या देखा बेटा? उन्होंने ये चीज देखी कि बाय चांस मैग्नेटिक नीडल उस टेबल पे था, वो कोई एक्सपेरिमेंट कर रहे थे किसी इलेक्ट्रिक सर्किट पे, मैग्नेटिज्म पे नहीं कर रहे थे। तो उन्होंने जब ऑन ऑफ किया तो उन्होंने क्या देखा कि ये जो नीडल है ये मूव कर रही है। जब उन्होंने डायरेक्शन चेंज की करंट की तो मैग्नेटिक नीडल की डायरेक्शन भी चेंज हुई। तो यहीं पे एक कंसेप्ट आया, यहीं से पता चला कि व्हेन देयर इज इलेक्ट्रिक करंट देयर इज मैग्नेटिक फील्ड। एंड यहीं से पता चला कि if there a moving charge can create magnetic field. A moving charge can create magnetic field. Dear student, now the question is, can electric field change its direction? This is the question. You just tell me, can electric field change its direction? Yes or no? Just pause the video and answer me. You got it right, dear students. Yes, the answer is yes. It can change its direction. An electrical field can change its direction. Suppose, dear students, we have an electric field here. Suppose we have another charge particle. From here, you can see the charged particle from here will goes down, down, down. It will turn. This charged particle, dear students, will turn until it will reach here and then it will go straight. So here we can see that it increases its velocity. So here in electric field we can see that it increases its velocity, and when it reach this direction then it will stop turning. It will stop turning and it will go along its direction after that. So it means that an electrical field can change its direction. You can see by here. Now we have a charge, dear student, and the charge is moving from this point to that, and it goes turning like this. Here the velocity remains same. Here the velocity of the moving charge remains same, but this is not the feature of electrical field. Here we can see that the velocity here increases, and then finally when it reaches its point here, then it goes straight and it will move with the same velocity, but here it increases. But you can see in this very example, here we have a charge and this charge is moving with the same velocity. Here we can say that कि ये जो वेलोसिटी है यहाँ पे कि ये इलेक्ट्रिकल फील्ड का फीचर नहीं हो सकता. Then what is it? Now the question is, ये किस चीज का फीचर है फिर? ये कौन सी चीज है? Are you getting? So dear students, यहाँ पे हमें ये चीज पता चलती है कि ये जो है ये इलेक्ट्रिकल फील्ड नहीं है, but this is magnetic field. This is magnetic field. When current flows, it means the current creates magnetic field, right? Okay, dear student, now the question is, what is the source of magnetic field? Till now we came to know that what is magnetic field. अब हमें ये पता चला कि ग्रेविटेशनल फील्ड, मैग्नेटिक फील्ड एंड इलेक्ट्रिकल फील्ड, these three fields in nature are totally different from one another, right? There might be a relation, but these fields are totally different. Okay. Now, the question is, what is the source of magnetic field? Dear students, you already knows that a magnet is made up of iron atoms. Is that clear? Magnet is made up of iron atoms, and you already knows that what is atom. Atom is made up of, there is a nucleus, right? There's protons, there are electrons, right? There are mesons, okay, and many more things. But what I mean to say that magnet is made up of iron atoms, and iron atoms are made of nucleus, electrons, right? Now the question is, what are electrons? आप जानते हैं इलेक्ट्रॉन्स क्या है, नेगेटिवली चार्ज्ड पार्टिकल्स इन एन एटम, राइट? वो चीज मुझे नहीं बतानी है, बट इलेक्ट्रॉन्स है क्या? These electrons are revolving around atom. This electron has a charge, right? Is that clear? First of all, let me tell you, these electrons are very, very much small particles. If we can say that, if we are going to combine 6 billion electrons, it can make just 6 centimeters of length, just 6 centimeters. And 6 billion is, around the population in our world, okay? These particles are very small particles of an atom. These electrons, these electrons have a charge, and they are moving around what? Around atom. Is that clear? Okay. I'm telling you that these electrons are moving charged particles. What I said, moving charged particles. I said moving charged particles. Earlier I said that a moving charge creates a magnetic field. So that means if this electron is a moving charged particle, so here the source of magnetic field is there. Source of magnetic field is there. It is just because moving charged particles create magnetic field. Okay, dear students. Okay, so I'm going to write the definition of the magnetic field. Till now we have discussed about the magnetic field. Dear students, this magnetic field is the characteristics in the space due to which a moving charge is necessary, dear students. Why you are going to study physics? If you are going to study physics, because it's the most interesting and important subjects in science, in scientific researches, in engineering field, in everywhere there is a physics. Okay, you need to clear each and every concept. If you are going to read the definition, then you must know that what is the meaning of the definition. So dear students, magnetic field is the characteristic in space due to which a moving charge experience a force. As I said, एक मूविंग चार्ज जो है वही एक्सर्ट एक्सपीरियंस कर सकता है क्या? फोर्स. किस एंगल पे? एट राइट एंगल to its motion, and then it turns. Okay, now the question is कि फोर्स क्या कर सकता है? क्योंकि हम फील्ड्स के बारे में पढ़ रहे हैं, अभी मैग्नेटिक फील्ड के बारे में पढ़ रहे हैं, तो ऑब्वियसली देयर इज अ फोर्स, राइट? तो ये जो फोर्स है, इट कैन डू थ्री थिंग्स. द फर्स्ट वन, इट कैन एक्सेलरेट, द सेकंड इट कैन रिटार्ड, एंड द थर्ड इट कैन टर्न. हमने अभी जो एग्जांपल में देखा था इलेक्ट्रिकल फील्ड के अंदर कि एक चार्ज जो है कैसी उसकी एक्सेलरेशन, कैसी उसकी वेलोसिटी बढ़ रही है, एंड देन की टर्न भी कैसे हो रहा है, और देन क्या देखा लास्ट पे कि रिटार्ड भी कैसे हो रहा है, क्योंकि अब वो उसी वेलोसिटी पे आ रहा था जिस वेलोसिटी से ऊपर चार्ज आ रही थी. इज दैट क्लियर? थैंक यू वेरी मच. ओके, सो नाउ द नेक्स्ट टॉपिक इज फोर्स ऑन मूविंग चार्ज। ये जो मैग्नेटिक फील्ड क्रिएट हुआ है, वहां पे ऑब्वियसली मैग्नेटिक फील्ड कहां पे क्रिएट होगा? जहां पे फोर्स एग्जिस्ट होगा, जहां पे फोर्स एग्जिस्ट होगा। इज दैट क्लियर? ना उस फोर्स पे उस चार्ज पे कितना फोर्स लग रहा है, दैट इज द क्वेश्चन। फोर्स ऑन मूविंग चार्ज, द स्टूडेंट्स फोर्स इज डायरेक्टली प्रोपोर्शनल टू magnetic field, that is B. Force is directly proportional to V, that is velocity. Let me explain you. Force is directly proportional to B, that's magnetic field, strength of magnetic field. And force is directly proportional to Q, that is charge. Dear students, suppose we have separate two rooms. एक रूम के अंदर अगर मान के चलिए कि एक चार्ज आ रहा है, मान के चलिए कि 1 मीटर पर सेकेंड की वेलोसिटी से, राइट? अगर उसकी वेलोसिटी बढ़ेगी तो ऑब्वियसली जो फोर्स है वो बढ़ेगा, इजंट इट? जितना वेलोसिटी बढ़ेगी उतना फोर्स बढ़ेगा। अब एक कमरे में ज्यादा स्ट्रेंथ है मैग्नेटिक फील्ड का, तो ऑब्वियसली उस कमरे में फोर्स ज्यादा होगा। दैट क्लियर? दूसरे कमरे में मान के चलिए कम मैग्नेटिक फील्ड है और उस कमरे के अंदर फोर्स कम होगा। और अगर दूसरे कमरे में पहले कमरे में मान के चलिए कि चार्ज ज्यादा है, जो चार्ज है वो ज्यादा है, मान के चलिए 20 कूलम है और दूसरे कमरे में 10 कूलम है, तो दूसरे कमरे के अंदर ये जो है फोर्स कम होगा, राइट? जितनी चार्ज होगी उतना फोर्स होगा, जितना मैग्नेटिक फील्ड की स्ट्रेंथ होगी उतना फोर्स होगा, जितनी वेलोसिटी होगी उतना ज्यादा फोर्स होगा। सो वी कैन इजीली राइट इट एज F is directly proportional to Q VB। ये देखिए हमारे पास एक इक्वेशन आ गई है। फोर्स इज डायरेक्टली प्रोपोर्शनल टू Q VB। प्रोपोर्शनलिटी को हटाने के लिए हम कांस्टेंट का यूज करते हैं, तो हम यहां पे कांस्टेंट का यूज करेंगे। F इज इक्वल टू K Q VB। अब हमने यहां पे ये जो कांस्टेंट है ये हमने हटाना है। फर्स्ट